Okay, so this is the second section of the binomial theorem. And as you can see, actually, you know what a binomial is. It's a plus b and to the nth power. So, it could be 0, 1, 2, 3, 4, 5, any of those, as I have there. So in this case, we have n equals 0, 1, 2, 4, 1, 2, 3, 4, 0, 1, 5. 0, 1, 2, 3, 4, 5. So I went ahead and wrote this out just to save a little time. But I do want you to notice a pattern here. But these are all the expanded versions. Okay. I also want you to note that anything to the 0 power is 1. I need you to graduate from high school knowing anything to the 0 power is 1, please. If you're a junior and going on to calculus, you also need to know that. So I did 0, 1, 2, 3, 4, 5, and now the question is going to be, let's expand a plus b to the 6th. Okay, but let's talk about this a little bit. Anything to the 0 power is 1, so you can see, I'm going to erase this one for a minute. Okay, so you can see that anything 0 power is 1, and then if you go down, I got a plus b to the 1 power, and look what I have there. All right, so I'm going to show you a plus b to the 1 power. We would typically write just a plus b, and that's what I have there, because I have 1, a to the 1, b to the 0, then 1, a to the 0, b to the 1. Well, anything to the 0 power is 1. 1 times 1 is just 1. So I have a to the 1, or just a, plus b to the 1, which is b. So I have a plus b. It's just a little bit more of a formal way to write it, because we need to see the patterns here. Okay, then I have a plus b squared. So you know how to do that squared. You have a plus b times a plus b, a squared plus ab plus ab plus b squared. So we got a squared plus 2ab plus b squared. Okay, that's what I have there. I have 1 a squared b 0, so that's just a squared, plus 2a1 b1, which is just 2ab, plus 1 to the a0 b squared, which is just b squared. Okay, so that is, and notice all the exponents have to add up to 2. That's the number I'm using, so they're all adding up to 2. 2 plus 0, 1 plus 1, 0 plus 2, all add up to 2. That's kind of an important thing we need to note. And now look on the next one. 3 plus 0, 2 plus 1, 1 plus 2, 0 plus 3. It all adds up to 3. Okay, we will be using that in the future. So kind of wanted you to notice the pattern there. Okay, and also notice that like we go up with our a's and down with our b's. So I got a to the 4th, a to the 3rd, a squared, a1, a0. And then I got b to the 0, b1, b2, b3, b4. So my a exponents numbers go down, my b exponents go up. And then they all add up to, in this case, 4. Okay, and the 5th, so a5, a4, a3, a2, a1, a0. Then b to the 0, b to the 1, b to the 2, b to the 3, b to the 4, b to the 5. And then they all add up to 5. Okay? All right, so I'm going to, before we answer the question of a plus b to the 6th power, I'm going to show you something called the Pascal's triangle. Okay? I'll try to make some space here. Okay, the Pascal's triangle is formed from all of these coefficients. Okay, coefficient is these numbers before the letters. That's coefficients. Okay, I'm circling all these. This is a coefficient. This is 1, 4, 6, 4, 1. There's coefficients 1, 5, 10, 5, 1. All the coefficients. See, they're all going to be forming this thing I'm going to call Pascal's triangle, which goes on forever and ever, but I'm just going to do a little bit of it to show you kind of how it works. Okay, so I'm just using the coefficients. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 5, 1, 5, 10, 10, 5, 1. Okay, so those were all just the coefficients that I just wrote from the above part. Okay, so that's where n equals 0. This is where n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, just from above. Same thing I've got up there. Okay, so here's where the pattern comes in. All right, notice all of your numbers there. Okay, so 1 plus 1, what does that equal? 2. Look at that, there's 2. Okay, and that follows all the way down. Now, we never change the outside numbers. They're always going to be 1. So those don't ever change. The further out your triangle gets, still was 1 on the front, 1 on the end. Okay, so let's do this. 1 plus 1 is 2. You got 2 plus 1 is 3. 2 plus 1 is 3. We got 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Look at that. Crazy how that works, right? So then I got 4 plus 6 is 10. I got 4 plus 1 is 5. 6 plus 4 is 10. 4 plus 1 is 5. So there is a pattern here that forms from this triangle, and we can just keep going. Right? This doesn't stop. So we're going to make the next line, which would be n equals 6. So I've got 1 plus 5, which is 6. 5 plus 10, which is 15. 10 plus 10, which is 20. 10 plus 5, which is 15. And 5 plus 1, which is 6. And then our last number is 1. Okay, and that would be n equals 6. So how you would write this is 1, a to the 6, b to the 0. And then we're going to go down in the a's, up in the b's. 6, a to the 5th, b to the 1, plus 15, a to the 4th, b squared, plus 20, a to the 3rd, b 3rd, plus 15, which is a squared, b to the 4th, plus 6a1, b 5th, and then 1. Oh, I ran out of room. Hold on just a second. 1, I'm going to move it to the next line. So 1a to the 0, b to the 6th. Okay? Now, if they asked you to expand it, you cannot write it like this. You cannot put in a to the 0, because a to the 0 is 1. Okay? b to the 0 is 1. And we don't typically write 1s as coefficients. Okay? So here's how you would write it. I'm going to erase a little space up here. So we would write a to the 6th plus 6a to the 5th, b, oops, not b to the 1, let me go back. So we would not write b to the 1, just b, plus 15, a to the 4th, b squared, plus 20, a cubed, b cubed, plus 15, a squared, b to the 4th, plus 6a, b to the 5th, plus b to the 6th. That's how you would write the answer right there. Okay, you don't typically write 1s as coefficients. We do here just to keep our placeholder kind of thing. You don't typically write 0s as exponents. Again, that's just kind of a placeholder to help you. Okay, so when you're entering it in, make sure you kind of be aware of the, anything to the 0 powers 1, that kind of thing. Okay. All right, so let's see how to kind of use this. Now, the coefficients, we're going to find out a different way to use the coefficients. To find the coefficients besides the triangles. Sometimes you don't want to just make the triangle out, but if you know the triangle, if you know 1 through 6 right now, let's say I would use the triangle. 15, probably not going to sit down and expand the triangle. I'm probably going to use what I tell you to use later on to find coefficients. Okay, so we're going to expand the binomial. So we know the fourth because we just did it before. All right, we just did it like the page before, see, where I had a to the fourth right there. So I'm going to write that down. Okay, so I've got a to the fourth plus 4a3b plus 6a squared b squared plus 4a cubed, no, 4ab cubed, sorry, plus b to the fourth. Okay, so that was from the page before, the triangle before. Hopefully you've written that down because it will come in handy. If you have 1 through 6, let's say. There's a 1 right there, remember, and there's 1 right there, but we don't really care about them because those are the coefficients, 1, 4, 6, 4, 1. Remember that from our Pascal's triangle. Okay, all right. So we're going to now like compare that to the binomial that they want us to expand, which is the 2x minus y squared to the fourth. Okay, so I'm going to write it kind of underneath so you can kind of relate the two. All right, so a is 2x, and b is negative y squared. Okay, so then we're just going to go through and fill in all the a's and b's. So 2x to the fourth plus 4 times 2x to the third, negative y squared, the 1, plus 6 and 2x squared times negative y squared squared plus 4 times 2x times negative y squared cubed plus negative y squared to the fourth. Okay, and now I just have to do the math of it. So 16, because 2 to the fourth is 16, so 16x to the fourth. Then I have 4 times 2 to the third. 2 to the third is 8, so 8 times 4 is 32, times negative 1. So that's going to be negative 32 x cubed y squared plus, and then I have 2 squared, which is 4 times 6, so 24. Negative 1 squared is a positive, so positive 24 x squared y squared. Oops, that should be y to the fourth right there. I'm re-recording this and I'm not writing on it, so by the way, that should be 24x squared y to the fourth minus 8x y to the 6 plus y to the 8th. So that is the correct answer, except for that should be 24x squared y to the fourth. I just noticed that mistake. I re-recorded this at least 4 times, so I'm probably not going to start over. Anyways, those numbers come from the Pascal triangle. Okay, so let's look at one that we want to do if you don't know the coefficient, okay, and we don't want to exactly expand out the 15 there, you know, like I don't want to do the triangle that far down. So I'm going to show you kind of how to do that. It's going to have to do with the combinations that we did on the section before this, okay. So we're going to relate the a plus b part, the triangle at the very beginning, the 15th. I want x to the 10, so I'm going to make x and a kind of related. I've got some coefficient that I'm going to tell you how to find in just a minute. Then I've got a to the 10 and b to the 5, and you might think, how do I know it's b to the 5? Well, it has to add up to 15. Remember that from the very beginning, and I told you that was important, that the exponents add up. So see how they add up to each other. 5 plus 0, 4 plus 1, 3 plus 2. So that is important in this case. We don't want to do the whole thing. We just want to do this specific term. Okay, so a plus b, except now we have x plus 2 to the 15th. So a is equal to x, and b is equal to 2 here. Okay, so I'm going to have some coefficient, and I'm going to tell you how to find that in just a second. And then I have a is x now, so x to the 10th, and b is 2, so 2 to the 5th. Okay, so I'm going to do the math here. 2 to the 5th is 32. Okay, here's how you find the coefficient. We're going to use our combination formula. Okay, so pretend like you have like 15 spots, and we want to find the 10th spot. So we're going to use our combination formula from last section. Okay, so I'm going to have the combination. And 15, and then I want the 10th spot. Okay, and I'm going to go to my calculator. I'm going to go to the math button. I'm going to go over the probability. I'm going to go like the third one down, and I'm going to put this in my calculator. Okay, you can use a formula if you want to, or you can just use the actual buttons that you can fill in to find this number. It's 3003. Okay, then times x to the 10th times 32. And then I'm going to do 3003 times 32. My calculator. And it is 96,096 x to the 10th. So my coefficient here is 96,096. So be sure when it asks for your coefficient that you're not putting in the x also, because it probably will count it wrong. So coefficient is just the number. Okay? All right, I'm going to do another one. This one's straight off your homework. I've just picked a problem off the homework. I mean, it may not be exactly the same one you have, but somebody will have it. Okay, so I'm going to find the coefficient x to the third and x minus 6 to the 8th. So a plus b to the 8th. Let's remember, we want some coefficient. Remember, I'm going to get there. I'm going to do a to the third, b to the 5th, because 3 plus 5 has to add up to 8. Okay, now I kind of like to write it underneath so I can line it up. So a equals x, and b equals negative 6. All right, so I have some coefficient I'm going to get to in just a minute. Okay, and then I have x to the third, and then I have negative 6 to the 5th. This is when you need to start using parentheses, you guys. So make sure you put parentheses around something when you try to square it or fifth it or whatever. So I have c is a combination, 8 and then 3. Put this in my calculator. And I get 56. And then I'm going to multiply it by negative 6 to the 5th. Okay, I'm going to get that number. So it's going to be this is going to be a negative number, because negative 6 to the 5th power is going to make it a negative number. So negative 435,456 x to the third. There's my coefficient. Okay, so hopefully this is pretty straightforward. Let me know if it's not. I'm going to do one more example, I think, off of your homework. Oh, I almost forgot to tell you. Do you remember we talked about this last section, but we talked about this little the way to write this just briefly. So there are some that say like simplify and have a 14 and a 6 written like that, and that's when you use your combination. You just write 14 and 6 in your calculator, and you spit out the answer. Okay, that is only for a combination. You can only write that, like I said, for a combination, not for a permutation. We kind of talked about different ways to write it in the last section. I mean, I just briefly talked about it because they briefly talked about it, but then it appeared this section. So I want to make sure I went over that again so you didn't have to remember that. But we also talked about it kind of being, another way to write it would be C and then parentheses N comma R. You can write permutation like that too, but you can't use the big parentheses like they're showing here for permutations. It's only for combinations. So that's good to remember, you know, if you're doing ACT, SAT or something like that. That's only for combinations, Okay, so I want to go over that. So you've got a couple of those easy questions that you literally just put in the calculator and use the two numbers they gave you. Okay, so I am going to do one more example. We're going to expand this right here, x minus 11 to the fifth. Now remember, I'm going to go back to my Pascal's triangle. I'm going to do what I need to do on Pascal's triangle. So those are the numbers from the Pascal's triangle. So now I'm just writing it out. Okay. All right, and so now I'm going to relate a plus b to the fifth to x minus 11 to the fifth power. So a would equal x, and b is going to equal negative 11. Don't forget that negative, or you are going to get it wrong because you're going to have some negatives here. Okay, and then you just go through and fill it in for all the x's, all the a's, all things. Okay, so notice I'm just filling in all the x's, all the negative 11s, and then I'm just going to do the math. I'm going to do the calculator out. I'm not going to wonder what these numbers are. I'm literally going to get a calculator out. If you're squaring something, please put parentheses around it. Be careful, careful, careful with negatives and positives here. So here is my answer. Notice I'm going from negative to positive, because if it's to the 1 power, it's negative. It's just 2 power, it's positive. 3 power, it's negative. 4 power, it's positive. 5 power, it's going to be negative. So here is my answer that I would write in my little answer box on the computer. Okay, so make sure you pay attention to your pluses and your minuses, especially when you're putting them in the calculator. All right. This might seem like it takes a long time, but think about if you try to multiply this out 5 times, how long that would take. Y'all think 3 takes a long time, and it does, but think about that. So this doesn't take as long, especially when you have your handy-dandy calculator and you can just use your handy-dandy calculator. So that's why mathematicians use the Pascal triangle. It comes in very handy when you're doing these a lot. All right, see you later.